The function f is given by f of x equals 3 to the x minus 3 as the exponent, and its graph is shown above. So, first things first. Okay, this is the same thing as 3 to the x, but since you have x minus 3 inside the parentheses, you move to the right 3. Okay, move to the right 3. Is that at all what I want to do? No. Which of the following is the equivalent form? So that's not at all what I want to do. So I just have a picture for no reason whatsoever. What they want me to do is they want me to turn 3 to the x minus 3 into one of these guys. Now, whenever you get two things being added together as an exponent, it's because you multiplied terms of the same base. So now that I don't need this anymore, let me back it up a little bit. Let me go in reverse. If I gave you a problem like 3 to the x times 3 to the fourth, you would say these are terms of the same base. Let's add the exponents 3 to the x plus 4. What must these be in order to get something like this? Well, that 4, if that was a negative 3, would have me adding the exponents, and x plus negative 3 is x minus 3. So I can rewrite this as 3 to the x times 3 to the negative third. Now, is that an option? No, 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 and no. Now, what I do know is 3 to the negative third can be written out as 1 over 3 to the third. So I have 3 to the x times 1 over 3 to the third. Is that an option? No. So let's take it one step further. 1 over 3 to the third can be written as 1 over 3 times 3, 9 times 3, 27. So is 3 to the x times 1 over 27 an option? Sure is. So what's the point of this picture right here? Nothing. Nothing at all. Tricked you.